How does chrome plating happen? Let us look at simplified process. We put an anode of lead alloy into a bath with solution of chromic and sulfuric acids and connect it to the positive pole of electric current source. Afterwards, we put the part into the same bath and connect it to the negative pole of electric current source. When the circuit is closed, electrolysis process begins, where electrons move towards the anode and metallic chrome settles on the cathode, plating it. The difference of nanodiamond chrome plating is that nanodiamond suspension is added to solution of chromic and sulfuric acids. At collision with nanodiamonds, chrome particles fractionize into smaller particles that settle on the part. What is the value of such technology? In order to understand that, it is necessary to know that the surface of each, even well-polished part has certain roughness, complex of surface irregularities. Thus, during traditional chrome plating, coating particles are unable to fill all irregularities of the metal. During nanodiamond chrome plating, metal cavities get filled much more densely. As a result, water residue on the chrome layer causes metal corrosion and coating detachment. Nanodiamond chrome plating provides much better protection against water and corrosion. Besides, this technology provides multiple enhancement of coating quality features, such as wear resistance, micro-hardness, hydrophobicity, etc. Such coatings provide for significant increase in durability and features of the part, for example, a turbine blade. Our company was established in 2004. On 15th of September 2018, we celebrated already 14 years. During this time, we have done much good and useful for our homeland, Russia. During this time, we have made over 15 inventions, completed over 20 R&D projects, and most of our projects are not to be shelved. All of them bring real results. And I would say I'm sure that some parts, for example valves for oil pumps or cables for spacecraft or epoxy with nanodiamonds, will very soon find broad application in our industry. Could you please tell what other parts except for turbine blades could be subject to nanodiamond chrome plating? Such plating has core difference from traditional chrome coatings that are now in use both in Russia and abroad. Those I had to deal with were mostly used for cylinders, plungers, pistons, etc. But since I understood that we are dealing with quite exotic, super high quality product, film or nanodiamond chrome, it's clear that first parts we have been plating were mostly fillers for extruder machines. Fillers are still our milk cows. They account for 15 to 20% of our order portfolio. We have developed spool valves for oil pumps, like this. They are patented. They have been and are in operation in over 3,000 wells in Russia, the US, Canada, China, India, Kazakhstan, Belarus, Syria, etc. This is what the spool of an American valve looks like after 1 month of operation in one of the Rosneft wells in Udmurtia. And this is what the spool of our valve looks like after 5 years, after 28 million cycles in a Tatneft well, namely in Nurlatneft. We have significantly outrun the American products. The fact is, we now have over 50 interested organizations for whom we have already plated some parts before and who are willing, based on this experience, to order plating of further 100, 200 or say 1000 parts. According to our estimate, Russian market for nanodiamond chrome is over 90 billion rubles annually. Nanodiamond chrome is 10 to 50% cheaper than currently used traditional chrome. Coating thickness can be reduced 2, 3, 5, and even more times. We have almost zero waste, since chrome settles and does not detach. Besides, we make the rigging and conduct full plating. It does not require further grinding or polishing and can be put into equipment. Plus economy on electricity, economy on payroll, economy on waste, economy on air ventilation, etc. So I am quite sure that cost of nanodiamond chrome is 10 to 50% lower than cost of traditional chrome. We sell our coating with around 300% margin. Payback period is from 10 months to 1.5 years, depending on client's condition. We have already trained on chrome and iron, and then a new task emerged: to coat copper cables with silver for space industry. While coating copper conductor with nanodiamond silver, we have developed a so-called space cable for Hrunichev Space Research Center. As far as I know, even nowadays, cables for spacecraft and aircraft production are purchased abroad. Our work is published, patented, and ready for implementation. For contacts in electronic devices, for cables, military-grade copper cables. We have already reached agreements with 2 companies dealing with precious metals that they implement nanodiamonds, silver, and gold, while we provide them with complex service, including development and reconciliation of technical conditions. We have been gradually moving from galvanic plating to polymer composite materials, where we put nanodiamonds into epoxy and PTFE as cable isolation, which actually was a little revolution. Currently, we are working on implementation for epoxy. Medical application is an interesting topic, taking into account that our colleagues who produce and implement nanodiamonds have been actively conducting research all across the globe, as it appears, for over 20 years. As it appears, our organism is tolerant to nanodiamonds. They do not settle or accumulate given certain size. It has been proven in multiple labs in Israel, Japan, the US, etc. That is why it is challenging for me to try myself as manager or co-manager of some medical projects. Our Russian colleagues have significantly moved toward enriching nanodiamonds with components for treatment of central nervous system, strokes, etc. As such tests on our smaller brothers, mice, rats, rabbits, have already been completed. I hope that we will soon manage to secure funding and develop those products up to biosupplements and medicines. There is another topic that I consider even more interesting: testing and production of creams, both medical ones and against wrinkles. I think that introduction of nanodiamonds through skin via creams is extremely perspective, up to enabling us to treat men and women with their typical gender-specific illnesses. I am ready for more detailed discussion regarding medical application of nanodiamonds. But, to be concise, in my opinion, the first of the greatest inventions of humanity was the wheel. The second was invention of a car. And the third, I hope, will be awareness of detonation synthetic nanodiamonds as medicine introduction vehicle for treatment of numerous illnesses.